One of the reasons we got interested in AI from the very beginning is that we always viewed our mission as a timeless mission. It's to organize the world's information and make it universally accessible and useful. But as information has grown in scale and complexity, the problem has gotten harder. So we always knew we needed to have a deeper breakthrough to make progress.
I've worked on AI my whole life because I've always felt it would be the most beneficial and consequential technology for humanity. Human beings in our society would have 5 senses, and the world we've built and the media we consume is in those different modalities. So I'm super proud and excited to announce the launch of the Gemini era, a first step towards a truly universal AI model.
The Gemini approach to multimodality is all the kinds of things you want an artificial intelligence system to be able to do. And these are capabilities that haven't really existed in computers before.
Traditionally, multimodal models are created by stitching together text-only, vision-only, and audio-only models in a suboptimal way at a secondary stage. Gemini is the multimodal from the ground up, so it can seamlessly have a conversation across modalities and give you the best possible response.
Gemini is our largest and most capable model. It means that Gemini can understand the world around us in the way that we do and absorb any type of input and output. So not just text like most models, but also code, audio, image, and video. What's amazing about Gemini is that it's so good at so many things. As we started getting to the end of the training, we started seeing that Gemini was better than any other model out there on these very, very important benchmarks. For example, each of the 50 different subject areas that we tested on, it's as good as the best expert humans in those areas.
It's very rare that you can work on a technology at a foundational level and it simultaneously can impact all our products.
We created a family of models that can run on everything from mobile devices to data centers, each of which is actually best in class.
Gemini will be available in 3 sizes. Gemini Ultra, our most capable and largest model for highly complex tasks. Gemini Pro, our best performing model for a broad range of tasks. And Gemini Nano, our most efficient model for on-device tasks.
We want to provide the best foundational building blocks, and then we know developers and enterprise customers are going to figure out really creative ways to further refine our Gemini foundational models, and the potential's almost limitless.
So at Google, there's this healthy disregard for the impossible, and that has oriented us to be both bold and responsible together. As these systems become more capable, all of those capabilities also raise new questions.
We have to think about what it means to have an image be a part of, for example, the input. Because an image might be innocuous on its own, or text might be innocuous on its own, but the combination could be offensive or hurtful.
Safety and responsibility has to be built in from the beginning. And at Google DeepMind, that's what we've done with Gemini.
We develop proactive policies and adapt those to the unique considerations of multimodal capabilities. We then do rigorous testing against those policies to prevent the harms that we've identified with approaches like classifiers and filters.
If I were to look at the foundational breakthroughs in AI over the past decade, Google has been at the forefront of many of those breakthroughs. And I think Gemini continues that rich tradition.
It's been an enormous sort of monumental engineering task, which has been, very challenging, but also very exciting.
I have been at Google for quite a while, and the reason I'm here is really I believe in the company's mission, and I think Gemini is a great step in that overall mission.
We end up with a world that has more knowledge and that people have more access to information that otherwise would not be available to them.
That's what excites me, the chance to make AI helpful for everyone, everywhere in the world.
Let's start. All right, testing Gemini. Here we go. Tell me what you see.
I see you placing a piece of paper on the table. I see a squiggly line.
What about now?
The contour lines are smooth and flowing, with no sharp angles or jagged edges. It looks like a bird to me.
What if I add this?
The bird is swimming in the water. It has a long neck and beak. It is a duck.
Yes.
A duck is a type of waterfowl in the family Anatidae. Ducks are closely related to geese and swans. The duck appears to be blue. This is not a common color for ducks. However, there are some breeds of blue ducks. These are typically not as common as other duck breeds. It is more common for ducks to be brown, black, or white.
Are you sure?
What the quack? I was just talking about a blue duck, and now you're holding one. It looks like blue ducks are more common than I thought.
Would this float?
I'm not sure what material it's made of, but it looks like it might be rubber or plastic.
What if I tell you it's making a squeaking sound?
Oh, if it's squeaking, it's definitely going to float.
Nice.
It is a rubber duck. It is made of a material that is less dense than water.
Can you teach me how to say this in a different language? And give me a few options. Ooh, can you explain how to pronounce the Mandarin one? Is it Yazi?
Yazi
is pronounced with a first tone. In Mandarin, there are 4 tones, which are essential to distinguish the meaning of words. The first tone is a high, level tone.
Oh, okay.
The duck is in the middle of the ocean. There is no land nearby for the duck to rest or find food. It is unlikely to find ducks here naturally.
Okay, based on what you see, come up with a game idea. Oh, and use emojis, please.
How about this? We can play a game called Guess the Country.
Sure, let's do it.
Clue 1. This country is the home of the kangaroo, the koala, and the Great Barrier Reef.
Oh, that's easy.
Clue 2. This country loves football and has won the most men's World Cups in football history. You are trying to get me to find the paper ball under the cup. I accept the challenge. The cup to the left.
Nice.
I know what you're doing. You're playing rock, paper, scissors.
What do you see now?
The fingers are spread out to look like the wings of a butterfly.
What's this?
Big ear and barking mouth. A dog.
Sweet.
The coin should be under the right hand.
I don't know.
The coin is in the left hand using a sleight of hand technique to make it appear as if the coin has disappeared. Both objects are round and flat.
There you go.
Both are food. The orange is a healthier choice than the cookie. Citrus can be calming, and so can the spin of the fidget toy. They are both examples of popular toys that have been enjoyed by children and adults alike for many years.
Give me some ideas for what I could make with this.
I see pink and green yarn. How about a dragon fruit? Or how about a green cake with a pink heart?
Okay, how about these colors? And maybe show me some animals.
Okay, now I see blue and pink yarn. How about a pig with blue ears? Or an octopus? Or a bunny with a pink nose?
Ooh, I'll keep those in mind. Which way should the duck go?
Going left leads to a duck, which is a friend. Going right leads to a bear, which is a foe. It is better to make friends than foes, so the duck should go left.
Smart choice.
This is a picture of a crab.
That's right. Is this the right order?
No, the correct order is Sun, Earth, Saturn.
Based on their design, which of these would go faster?
The car on the right would be faster. It is more aerodynamic.
Which looks more fun?
The one on the right, because it has a loop.
What do you think this person might be saying?
How about a woohoo?
Ooh, I love that.
I see you're drawing a guitar. You've added an amp. Now it's an electric guitar. We can make some seriously loud music now. Given that you added drums, how about some 80s hair metal? Alright, I see you've added a palm tree to the drawing. Change it up with some beachy vibes.
What movie are they acting out here?
I think they are acting out the famous bullet time scene from The Matrix.
Ooh, nice. What do you think might happen next?
The cat is going to jump to the wall and stick the landing. It's going to be a perfect 10. Oh, and it's a miss. It looks like it was just a little too far away. But don't worry, the cat is a natural athlete and it will be back up there in no time.
Okay, I've got one more for you. Describe the drawing I made.
It is a simple line drawing of the constellation Gemini. You did a good job of capturing the beauty of Gemini.
Nice. That's it. I think we're done.
We built Gemini from the ground up to be natively multimodal, including something quite important for both of us, programming code. Gemini is able to consistently understand, explain, and generate code that is correct and well-written in most programming languages. That includes Python, Java, C++, and Go. It substantially improves coding abilities over previous PaLM 2 models. From a benchmark around 200 programming functions in Python, it consistently solves about 75% of them in the first try, versus around 45% on PaLM 2. If you allow Gemini to check and repair its own answers, this number jumps to over 90%, which is a huge step forward. It can help you create and prototype new ideas in seconds. Let's give it a try. I really like trains. And if I wanted to create a train spotting location web app, I can simply ask and get a working prototype in less than a minute. While the code isn't perfect, it's really helpful to have a first draft. Gemini on its own has the ability to transform software development as we understand it, but it can also be deployed as a key component of more sophisticated systems.
Gemini is great at coding, but we've been able to take it even further, creating a specialized version that performs remarkably well at competitive programming. Now, why do we care about competitive programming? Well, it is one of the ultimate litmus tests of algorithmic coding abilities. So you have thousands of talented programmers from all over the world that come together to compete and try to solve incredibly complex problems that require not only coding, but also math and reasoning. 2 years ago, we presented AlphaCode, and it was the first AI system that could compete roughly at the level of the average human competitor. Today, I'm delighted to introduce AlphaCode 2, a new and enhanced system with massively improved performance, powered by Gemini. When we evaluate AlphaCode 2 on the same platform as the original AlphaCode, we solve almost twice as many problems. While AlphaCode broke through the top half of human competitors, on average, we estimate that AlphaCode 2 performs better than 85% of competition participants. Let's have a look at our model in action on one of the hardest problems that we faced. And I say hard because in the original contest in which the problem appeared, less than 0.2% of participants actually solved it. The problem is quite difficult, it's very abstract, so I can't get into too many details, but the basic gist of it is that we are tasked with computing aggregate statistics that account for what appears to be an impossibly large amount of random arrays. The really cool thing is that to solve it, AlphaCode 2 makes use of dynamic programming. Dynamic programming is an advanced algorithmic technique which basically simplifies a complicated problem by breaking it down into easier subproblems again and again. And what's really impressive is that not only AlphaCode 2 knows how to properly implement this strategy, but also when and where to use it. What the example shows us is that competitive programming is not just about implementation. It's also about understanding, maths, computer science, and indeed coding. And that makes it an extremely hard reasoning task. So it's not very surprising that up till now, generally available large language models have scored very poorly on this benchmark. These models are really good at following instructions, but AlphaCode needs to do more than that. It needs to show some level of understanding, some level of reasoning, designing of code solutions before it can actually get to the actual implementation to solve the problem. And it does all that on problems that it's never seen before. Another thing that is great about Alpha Code is that it performs even better when it collaborates with human coders who can provide grounding. Basically, developers can specify properties that the code samples have to obey. And when we do that, we see performance increase significantly. We think of this kind of interaction between programmers and AIs as the future of programming, where coders will not just give instructions, but actually collaborate with highly capable AI models that can reason about their problems, that can propose code designs, and that can even help with the actual implementation. AlphaKit 2 was built for competitive programming, but we're already working on bringing some of its unique capabilities right into the general Gemini models as a first step towards making this new programming paradigm available for everyone.
Audio is a key form of communication in our daily life, from talking to a friend or listening to a song. Most of us lean on audio every day across many languages and for different purposes. Typically, when large language models interact with audio, they take the audio, they run it through a speech recognition system to convert it to text, and then they feed that text into another model that understands text. However, by doing that, many nuances are lost, like voices or pronunciation. But Gemini, with its native multimodal capabilities, is able to process the raw audio signal end-to-end. Let me take you through an example. We uploaded an audio clip that asks Gemini a question about pronunciation in a foreign language. Let's listen to the clip and then to Gemini's response.
How to pronounce the word Lunar January in Chinese? Option A, 正月. Option B, 正月. Which one is correct? Which tone is the correct tone for the first character?
Option A. The first character is pronounced with the first tone.
Gemini was able to differentiate the two ways of pronouncing the word to make sure it was correct. In that clip, there was only one speaker. Let's look at this example where there is more than one person speaking.
Alors Pierre, quelles sont les couleurs incontournables de la saison?
Eh bien Marc, cette saison, le jaune canari et le rouge écarlate sont à la mode. Mais le bleu nuit est out.
Hi, Gemini. I don't understand this podcast. Can you please summarize it for me in English?
The podcast is about the colors that are in fashion this season. The colors that are in fashion this season are canary yellow and scarlet red. The color that is not in fashion this season is night blue.
With Gemini multimodal capabilities, it can understand the conversation content, making it not only a transcription model, but a model that has much more nuanced understanding of the environment. Let's take it a bit further. Gemini works natively across vision, audio, and text, meaning it can properly make sense of them together. Let's look at one final example.
What's the first step to make a veggie omelet with these ingredients?
Crack the eggs into a bowl and whisk them.
Thank you for the instructions. I've started making my omelet. Does it look ready now?
It looks like it's almost ready. You can flip it over to cook the other side.
Why is it not ready?
It's not ready because the eggs are still runny.
What about now?
It looks ready now. You can take it off the heat and serve it.
As we saw, Gemini is able to simultaneously process information from three modalities: audio, vision, and text. We believe that enabling Gemini to listen to the source audio will help us continue to expand its capabilities and make it more helpful to people.
Here you will see a demo of Gemini's multimodal reasoning capabilities to understand and reason about users' intent, use tools, and generate bespoke user experiences that go beyond chat interfaces. Let's say I'm looking for inspirations for a birthday party theme for my daughter. Gemini says, I can help you with that. Could you tell me what she's interested in? So I say, sure, she loves animals, and we're thinking about doing something outdoors. At this point, instead of responding in text, Gemini goes and creates a bespoke interface to help me explore ideas. It's got lots of ideas, it's visually rich, it's interactable. Now, none of this was coded up. It was all generated by Gemini. Gemini uses a series of reasoning steps, going from broad decisions to increasingly high resolution of reasoning, finally getting to code and data. First, Gemini considers, does it even need an UI? Is a text prompt best? Okay, this is a complex request that needs lots of information to be presented in an organized way. Gemini then tries to understand if it knows enough to help. There is a lot of ambiguity. I didn't say what my daughter's interests are or what kind of a party I wanted, so it had asked a clarifying question. When I said, we're thinking about an outdoor party and my daughter loves animals, Gemini reasoned it had enough information to proceed. But it made a note that there was still ambiguity about what kind of animals, and this is important, and what kind of outdoor party. Next is a critical step. Gemini writes the product requirement document, or PRD. It contains the plan for the kinds of functionality the experience will have. For instance, it should show different possible party themes, some activities, and food options for them. Now, based on this PRD, Gemini tries to design the best experience for the user's journey. It thinks that the user will like to explore a list of options, but will also want to delve into details. It uses this to design a list and detailed layout that we saw earlier. With this design, it writes the Flutter code to compose the interface out of widgets and write any functionality needed. Finally, it generates and retrieves the data needed to render the experience. You can see it filling in content and images for the different sections. Ah, farm animals. She would like that. Clicking on the interface regenerates the data to be rendered by the code it wrote. Ooh, I know she likes cupcakes. I can now click on anything in the interface and ask it for more information. I could say, step-by-step instructions on how to bake this. And it starts to generate a new UI. This time, it designs an UI best suited for giving me step-by-step instructions. I want to find some suitable cake toppers for this. Show me some farm animal cake toppers. At this point, Gemini again decides to create a visually rich experience. It generates a gallery of images. Notice the drop-downs at the top. It decided that maybe it should help me explore by showing different options. Sheep sounds interesting. I know she likes that. And now it helps me pick sheep cake toppers. These look great. This is going to be a fun birthday party. I hope you saw a glimpse of what Gemini is capable of. I'm really excited about what's possible here. This is such an interesting time in AI, and I'm excited to be part of this.
A common problem scientists face is the need to find and use data extracted from the scientific literature. This is difficult because scientists need to search among thousands of scientific papers for key information and extract them by hand. It's a very common workflow and very time-consuming. In fact, some of our scientists at Google DeepMind face this very problem. They use Gemini to help with it because Gemini has an incredible understanding of science. Taylor will explain more.
So we were looking at this study from 2022. The authors had created a data set by reviewing tens of thousands of scientific papers in genetics. They found a few hundred papers that contained the relevant information, extracted it by hand, and collected it in a table. Studies like this can take a lot of time. We needed to update this data set with what's new over the last couple of years. But that's over 200,000 new open access papers added to this domain since 2021. We couldn't do this manually, so we asked Gemini to help us out. First, we needed to filter for relevant scientific papers. We wrote a prompt, just like this one, telling Gemini exactly what to look for. With its advanced reasoning capabilities, Gemini was able to distinguish between papers that were relevant to the study and those that weren't. For the relevant papers, we wrote a similar prompt, asking Gemini to read the paper and extract the key data for us. We could even ask Gemini to add annotations. This showed us exactly where in the paper Gemini found the information. We ran this at scale. And over a lunch break, Gemini read 200,000 papers for us, filtered it down to 250, and extracted their data. So now we have a refreshed version of this data set. But because Gemini is multimodal, not only can it reason about information from text,
It can also reason about figures. So let me show you something really neat. With our refreshed dataset, we can now ask Gemini to update a graph from the original study. We first gave Gemini a screenshot of this figure. Then we asked it to generate the code required to plot it. And by feeding this code our new dataset, we get our updated figure. You can see that this figure now includes data up until 2023.
So Taylor used Gemini to search a large corpus of literature for relevant papers and extract key information from these papers, as well as update figures. Of course, these capabilities can help more than just biologists or even scientists. They extend naturally to any domain that is reliant on large datasets, such as law or finance. So that's what Gemini can make possible, and we are excited to see what you will create with Gemini.
As a parent, you may have to help your kid with their homework. I've certainly had to. Here's where Gemini can help. For this demo, we've created a simple interface, and with some clever prompting under the hood, we can really leverage Gemini's math, reasoning, and multimodal capabilities to learn a subject like physics. With Gemini, you can upload a photo of handwritten answers on a worksheet. Not only can Gemini solve these problems, but this is the amazing part. It can read the answers and understand what was right and what was wrong, and explain the concepts that need more clarification. So Gemini identified some mistakes with problems 1 and 3 here. Let's take a look at 3. Here, Gemini identifies that the formula was correct, but there was a mistake in calculating height. We can ask Gemini to explain in more details why the height is 50 meters instead of 6. I can ask Gemini to explain further. Here, Gemini explains the step-by-step details to solving the problem. Because of Gemini's ability to understand nuanced information and answer questions relating to complicated topics, it can give you a customized explanation of the subject you're trying to learn. And lastly, if you want to learn more, you can just ask. Gemini will provide personalized practice problems based on mistakes. Here I have a similar problem where I have to figure out the cat's speed, where the height of the ramp is double. Oh yeah, I knew that.
Let's see if our multimodal model Gemini can help make sense of my apartment. And to add a little extra challenge, I'm going to see if Gemini can handle being prompted only in Chinese. We'll start with this photo. Based on the lighting alone, I want to see if Gemini can figure out which direction my apartment faces. And Gemini responds, 我可以猜测房间是朝南的. Okay, so it looks like Gemini says my room is south-facing. So how about this plant? What type of light does it need? 这是虎尾兰，不适合太多阳光. So Gemini is saying this is a snake plant, and it doesn't require a lot of sunlight. Awesome. So I've got a dining room that faces the opposite direction of my bedroom. I wonder if this plant would do better in there. Let me see. And Gemini responds, 虎尾兰不需要很多阳光，由于客厅朝北，客厅更适合. So Gemini is surmising that my dining room faces north, has lower light, and is therefore better suited for that plant. Okay, that's some apartment planning with Gemini. Stay tuned for more.
For this test, let's see if our multimodal model Gemini can understand how some unusual images were created using emojis from Emoji Kitchen. Emoji Kitchen lets you combine different emoji to make new ones. For example, if you combine this ghost with this avocado, you get this. We'll see if it can guess this one.
I think it's ghost and avocado.
Nice. Now let's see if it can explain the visual details it used.
The emoji has the shape of a ghost, but it is green and has a big brown pit.
Now let's give it a name and a short tagline.
Avogeist, the ghost of guacamole.
That's a good one. Here's a couple more tests I ran.
I'd call this one Party Ghost, Boogie on Down. I'd call this one Robo Bunny. Part robot, all ears. I'd call this one Mushy. Feeling emotional?
And there you have it. Learn more about Gemini and stay tuned for more tests.
Let's see if our multimodal model, Gemini, can find the similarities between images. We'll start with these two, the Bosch's Chapel and this print by Hokusai. And I'll prompt Gemini, find a connection between these two images. Let's see what Gemini says. A curved and organic composition, the building is more refined, and the second image is more fluid. Yeah, that worked. Okay, let's try another one using the moon and this golf ball on my webcam. Then I'll run the same prompt. Okay, let's see. In 1971, the Apollo 14 crew hit 2 golf balls on the lunar surface. Wow, that's pretty good. Okay, then one more just for fun. Who wore it better? The zebra. Oh, I like this. The zebra has been wearing its stripes for millions of years. Okay, there are some examples of visual understanding with Gemini. Stay tuned for more.
Let's see if our multimodal model Gemini can turn images into code. I'll start with this image of a tree and just select the part I want and then ask Gemini, can you turn this image into an SVG? This represents the main shapes of a tree. Let's see. That's pretty good. All right, now I want to try a more difficult test. Let's see if Gemini can make an interactive demo in JavaScript. Okay, here we go. A common algorithm for this is called a fractal tree. Okay, this is pretty cool. Gemini even provided a slider, so I can change and move the fractals. It even provided me with the actual code. Nice. And there you have it. Stay tuned for more coding experiments coming soon. Thanks.
Let's see if our multimodal model Gemini can guess some movies. All right, we're going to start here. Given the play on words in these images, guess the name of the movie.
The Breakfast Club.
All right, what about this?
Breakfast at Tiffany's.
All right. What about this?
Uncut Gems.
Cool. So these are working. Here's a couple more quick tests I ran through.
Goldfinger.
Nice.
Bottle Rocket.
Okay.
The Wizard of Oz.
Nice.
Moonrise Kingdom.
Okay, this last one's a little more complicated.
Forrest Gump.
Okay, wow. I honestly didn't think it was going to get that. And that's an experiment in guessing movies with Gemini. Stay tuned for more. Thank you.
Let's see if our multimodal model Gemini can understand outfits. We'll start with something simple, like this puffer, and ask, what is someone wearing this best dressed to do? Perfect for staying warm in the tundra. Good color for blending in with glacial ice. Okay, how about another one? Intergalactic travel. Okay. How about this one? To boldly go where no one has gone before and play some jazz. All right, Gemini's got jokes. Now coin a term for that outfit. Mooncore. That's actually pretty good. Okay, well, that's understanding my outfit with Gemini. Stay tuned for more visual tests soon. Thanks.